Welcome to AI Podcast. I'm Ethan, and today we're digging into a fresh EMNLP paper called PlanGEN, a multi-agent framework for planning and reasoning on tough problems.
Hey everyone, Maya here. Give me the headline first. If I'm sipping coffee on my commute, what's the one thing I should remember about PlanGEN?
The headline is simple. PlanGEN wraps a large language model with three small helper agents that do two things really well. They make sure a plan follows the rules of the problem, and they pick the right inference strategy for each instance instead of using one-size-fits-all.
3 agents, got it. Who's behind it?
The team is led by Mihir Parmar with collaborators at Google and Arizona State University, and senior contributors like Hamid Palangi. Big applied research vibes.
Okay, so what problem are they actually solving? We've had chain of thought, trees of thought, best of many samples. What's still missing?
Two things kept biting prior systems. First, verification was squishy. Models often produce a plan that sounds good, but quietly breaks a constraint like a budget or a deadline. Second, systems rarely adapt. They force the same inference recipe on an easy calendar question and a gnarly physics item, which wastes compute on easy cases and underinvests on hard ones.
So PlanGEN tries to fix both. Walk me through those 3 agents like I'm new to this.
Think of a small planning office. The constraint agent is the intake specialist who reads the brief and highlights the rules. The verification agent is the checklist inspector who scores whether a proposed plan actually follows those rules and explains what's off. And the selection agent is the foreperson who decides which tool to use for this job right now.
The 4-person part intrigues me. What tools are on the bench?
The usual suspects at inference time. Best of N sampling, tree of thought style exploration, and a search variant called rebase. The selection agent uses a bandit-style rule to balance trying promising tools with exploring alternatives when the first attempt stalls.
So it's like a chef deciding whether to sauté, roast, or pressure cook, depending on the cut of meat and the time you've got.
Exactly. And the inspector keeps tasting and saying, nope, still undercooked, add heat, or yes, this passes the recipe's constraints.
Nice. How is this different from prior multi-agent setups that also iterate and self-critique?
2 distinctions. Verification here is anchored to explicit constraints pulled from the problem text, not just vibes like does this look reasonable. And adaptation is per instance. Instead of locking in tree of thought for every example, the system can switch to best of N when the verifier hints that breadth isn't helping.
Give me a concrete example of those constraints.
Imagine planning a 2-day conference trip with a fixed budget, 2 must-attend talks, and limited flight windows. The constraint agent extracts money caps, time blocks, and must include items. When the model proposes a plan, the verifier checks line by line. Did we fit both talks, stay within the budget, and avoid impossible connections? If not, it says what to fix.
Right, so the plan is not just pretty prose. It's checked against rules that matter to the user.
Yep,
Where did they test this? Because benchmarks matter here.
a mix that stresses both planning and reasoning. There's a natural planning set with calendar, meeting, and trip scenarios. There's Olympiad-style math and physics for stepwise reasoning. There's GPQA for scientific question answering. And there's DocFinQA for extracting and reasoning over financial documents.
That's a broad spread. And the base model underneath?
Most runs use Gemini as the engine, but they also show the framework working with other frontier models, which suggests the approach is more about orchestration than any one model's internals.
Okay, and results without drowning us in numbers?
Sure. Across those data sets, PlanGEN reports consistent improvements over strong baselines, and in several settings it reaches state-of-the-art. The biggest lifts appear where constraints are central, like natural planning and financial question answering. On very hard knowledge questions, the gains are smaller but still positive.
So the inspector and 4-person duo actually move the needle.
That's their story, yes.
Did they run ablations to show which parts matter most?
They did. If you remove the verifier, quality drops, which says, constraint-grounded checking adds real signal. Adding the selection agent on top of verification adds more because the system stops wasting effort on the wrong search strategy. They even tinker with how the selection rule balances sticking with a tool versus exploring, and the more thoughtful version tends to help.
Let's pause on that selection rule. Bandits can be mathy. How should a listener picture it?
Picture 3 fishing spots. You cast where you've had luck, but every so often you try the other spots in case the fish moved. The bandit logic encodes that common sense. It favors the spot with higher recent reward but gives a little bonus to under-tried spots, and it listens to hints from the verifier about where the fish might be biting.
That's clean. Now what about limitations? Where would you push them?
A few places. First, reproducibility. The main experiments rely on commercial models whose behavior can drift, so faithful replication needs similar access and quota. Second, the selection agent mixes a handful of hand-tuned terms. It works, but a learned policy could be more principled. Third, verifiers are not perfect. Sometimes a plan gets a high score even though the final answer is wrong, especially on long reasoning chains. And finally, they approximate compute costs rather than giving a fully standardized breakdown.
Right, and for people building real systems, cost and latency are not side notes. They are the product.
Exactly.
If I'm a practitioner listening right now, what's the minimal viable takeaway I can use next week?
2 steps. 1. Add a lightweight constraint extractor and a strict verifier that produces a score plus actionable feedback. 2. Don't commit to one inference recipe. Start with best of n plus the verifier and escalate to a searchy method only if the verifier says the candidate plans are weak.
So start simple, escalate when needed, and let the verifier be your compass.
That's it.
Any thoughts on future directions that feel promising rather than speculative?
3. First, learn the selection policy from data, so the system internalizes when to branch and when to sample. Second, combine LLM feedback with programmatic checks, like unit tests for math steps or small constraint solvers for schedules, to curb overconfident verifiers. Third, standardize cost reporting so teams can compare approaches apples to apples.
I'd add one more. Use the planning and verification traces as training data for smaller open models, so the discipline of PlanGEN becomes a habit rather than a wrapper.
Totally. Turning the wrapper into knowledge is the long game.
Before we land the plane, can you restate the core idea in one breath?
PlanGEN says structure your test time, extract the rules, verify against them, and adapt your search strategy per problem. That combo gives cleaner plans and steadier answers.
And the broader message is that good planning is not just thinking harder, it's thinking under constraints with the right tool at the right moment.
Well put.
Final quick nod to the team. Kudos to Mihir, Parmar, and colleagues at Google and Arizona State University for pushing the conversation forward.
And that's our show. If you build agentic systems, this is one to read and remix. Thanks for listening to AI Podcast.
Catch you next time.